ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. They do this by monitoring the current flowing in a circuit and tripping if they detect a difference between the outgoing and returning current, indicating a potential ground fault. However, GFCIs can sometimes trip unnecessarily, a phenomenon known as nuisance tripping. This can be particularly common with fluorescent lighting. Here's why and what can be done about it. Fluorescent lights can cause GFCI tripping for several reasons. Firstly, they produce electromagnetic interference, or EMI. Fluorescent lights generate EMI when they start up and operate. This EMI can interfere with the GFCI's sensing circuitry, causing it to trip even if there is no actual ground fault. Secondly, leakage current can also lead to GFCI tripping. Fluorescent lights can have small leakage currents due to the capacitance between the lamp and the fixture. This leakage current can be enough to trip a sensitive GFCI. Thirdly, high inrush current is another issue. When fluorescent lights are first turned on, they draw a large inrush current. This inrush current can overload the GFCI and cause it to trip. Fourthly, older fluorescent lights can experience issues because older fluorescent lights may have faulty ballasts or other components that can cause them to draw excessive current or generate EMI, increasing the risk of GFCI tripping. To address GFCI tripping with fluorescent lights, there are several steps that can be taken. First, consider using GFCIs with high nuisance trip thresholds. Standard GFCIs typically have a trip threshold of 5 mA. However, GFCIs with high trip thresholds, such as 20 mA or 30 mA, are available. These GFCIs are less sensitive to EMI and leakage current and may be less likely to trip unnecessarily. Second, ensure proper grounding. Make sure that all electrical equipment, including fluorescent lighting, is properly grounded. Poor grounding can cause leakage currents that can trip GFCIs. Inspect grounding connections and tighten any loose screws or terminals. Third, use ground fault circuit interrupters with neutral fault protection. These GFCIs can detect both line-to-ground and line-to-neutral faults, which may be more effective in preventing tripping from fluorescent lighting. Fourth, isolate fluorescent lighting on a separate circuit. If possible, separate the fluorescent lighting from other appliances and tools on the same circuit. This will reduce the load on the GFCI and make it less likely to trip. Fifth, use LED lighting. LED lighting consumes less power and generates less electromagnetic noise than fluorescent lighting, reducing the risk of GFCI tripping. Consider converting to LED lighting if possible. Sixth, use cordless tools. For handheld tools, consider using cordless or battery-powered options instead of corded tools that draw power from the GFCI protected circuit. Seventh, educate booth operators. Inform booth operators about the potential for GFCI tripping with fluorescent lighting. Encourage them to turn on the lights gradually or use step-up transformers to reduce the inrush current. Eighth, consider dedicated GFCI protection devices. There are dedicated GFCI protection devices specifically designed for fluorescent lighting. These devices can be installed in series with the lighting fixture to provide GFCI protection without tripping due to normal fluorescent lighting operation. Now let's look at the details of why some of these solutions work. A ground fault circuit interrupter, or GFCI, is a safety device designed to protect individuals from electrical shock. It works by monitoring the balance of electrical current between the hot, which is the energized conductor, and the neutral wires in the circuit. Under normal circumstances, the current flowing through the hot wire should exactly equal the current returning through the neutral wire. If there is a difference, it indicates that some current is leaking out of the circuit, possibly through a person who is touching a live wire. This leakage is called a ground fault. The GFCI is designed to detect these small imbalances in current, typically as low as 5 mA, and quickly trip the circuit, cutting off the power and preventing a potentially fatal electrical shock. The tripping mechanism in a GFCI is incredibly fast, usually interrupting the circuit within a fraction of a second. This rapid response is crucial in preventing serious injury or death from electrical shock. The sensitivity and speed of GFCIs make them highly effective in protecting against electrical hazards in wet or damp locations, such as bathrooms, kitchens, and outdoor areas where the risk of electrical shock is high. There are several types of GFCIs available, each designed for specific applications. Receptacle GFCIs are the most common type and are installed in place of standard electrical outlets. They provide protection for anything plugged into that outlet. Circuit breaker GFCIs are installed in the electrical panel and protect the entire circuit. Portable GFCIs are designed to be plugged into an existing outlet and provide temporary protection for tools and appliances. GFCIs are required by electrical codes in many locations, particularly in areas where water is present. They are an essential safety device for protecting against electrical shock and should be installed and maintained properly. In addition to protecting against electrical shock, GFCIs can also help prevent electrical fires. Ground faults can cause excessive heat, which can ignite flammable materials and lead to a fire. By quickly interrupting the circuit, GFCIs can reduce the risk of electrical fires. While GFCIs are highly effective, they are not foolproof. They can sometimes trip unnecessarily, a phenomenon known as nuisance tripping. This can be caused by various factors, such as electromagnetic interference or faulty appliances. However, even nuisance tripping is preferable to the risk of electrical shock. Grounding is another essential aspect of electrical safety. It provides a path for stray electrical current to flow back to the source, preventing it from flowing through a person or causing damage to equipment. Proper grounding helps to stabilize voltage levels, reducing the risk of electrical shock and equipment failure. There are several types of grounding systems, including equipment grounding, which connects the metal parts of electrical equipment to ground, and system grounding, which connects the neutral conductor of the electrical system to ground. The grounding system must be properly installed and maintained to ensure its effectiveness. Poor grounding can increase the risk of electrical shock, equipment damage, and electrical fires. It is important to have a qualified electrician inspect the grounding system regularly to ensure that it is functioning properly. LED lighting offers several advantages over traditional fluorescent lighting, including energy efficiency, long lifespan, and reduced maintenance costs. LED consumes significantly less energy than fluorescent lights, which can result in substantial savings on electricity bills. They also last much longer, reducing the need for frequent replacements. LED lights are also more durable and resistant to breakage than fluorescent lights, which contain glass tubes that can easily shatter. In addition, LED lights do not contain mercury, a hazardous substance found in fluorescent lights. This makes LED a more environmentally friendly lighting option. When choosing LED lighting, it is important to consider the color temperature and brightness. Color temperature is measured in Kelvin and indicates the warmth or coolness of the light. Lower Kelvin values produce a warmer, more yellow light, while higher Kelvin values produce a cooler, more blue light. Brightness is measured in lumens and indicates the amount of light emitted by the bulb. The appropriate color temperature and brightness will depend on the specific application. For example, warmer light is often preferred in living rooms and bedrooms, while cooler light is often preferred in offices and kitchens. Troubleshooting GFCI tripping can be a challenging task, but there are several steps you can take to identify and resolve the issue. First, try resetting the GFCI. If the GFCI trips again immediately, there is likely a ground fault in the circuit. Next, unplug all appliances and devices connected to the circuit and try resetting the GFCI again. If the GFCI resets and stays on, plug in each appliance one at a time until the GFCI trips. This will help you identify the faulty appliance. If the GFCI trips even with all appliances unplugged, there may be a problem with the wiring in the circuit. In this case, it is best to call a qualified electrician to inspect the wiring and make any necessary repairs. It is important to remember that GFCIs are designed to protect against electrical shock and should not be bypassed or disabled. If you are experiencing frequent GFCI tripping, it is important to identify and resolve the underlying cause to ensure your safety. Regarding specific code references, Article 525 of the National Electrical Code, or NEC, covers temporary installations, including those for fairs and similar events. Section 525.23 specifically addresses the requirements for ground fault circuit interrupter protection. The requirement is that all 125-volt single-phase 15 and 20 amp receptacles that are readily accessible to the public must have GFCI protection. The phrase readily accessible typically means that the receptacle is not behind a counter or otherwise obstructed from access by the public. The NEC doesn't explicitly state that fluorescent lighting requires GFCI protection. However, if the lighting is powered by a cord and plug connected to a receptacle that is required to be GFCI protected, then the lighting effectively falls under that protection. The fact that the lights are tripping the GFCIs indicates a ground fault issue, even if it's a minor one. The suggestions previously mentioned can help mitigate these trips. High nuisance threshold GFCIs are designed to tolerate small, normal leakage currents without tripping. Regular GFCIs trip at around 5 mA. A higher threshold GFCI might trip at 20 or 30 mA, allowing for the small leakage from the fluorescent lights without causing a nuisance trip. Proper grounding is crucial. A good ground connection provides a safe path for fault current to flow back to the source, allowing the GFCI to trip quickly and clear the fault. Inspect all grounding connections in the booth, the temporary panel, and the power source to ensure they are tight and properly connected. Using a ground fault circuit interrupter with neutral fault protection is a good idea. Standard GFCIs detect imbalances between the hot and neutral wires. A GFCI with neutral fault protection also detects faults between the neutral wire and ground, which can be a source of tripping in some lighting systems. If possible, separate the lighting circuit from other loads. If the lights and other devices, such as fans or tools, are all on the same circuit, the combined leakage current can be enough to trip the GFCI. Putting the lights on a separate circuit can isolate the problem. Switching to LED lighting is a great way to reduce the risk of tripping. LED use significantly less power than fluorescent lights and don't have the same inrush current or harmonic distortion issues that can cause GFCIs to trip. Finally, educating booth operators is important. Explain to them why the GFCIs are there and what can cause them to trip. Ask them to avoid plugging in multiple devices at the same time, especially when turning on the lights. If the problem persists after trying these solutions, consulting a qualified electrician is advisable. They can use specialized equipment to test the circuits and identify the source of the tripping. They can also ensure that the temporary electrical system complies with all applicable codes and regulations. Remember that temporary electrical installations for events like arts and crafts fairs have specific requirements to ensure safety. Following these requirements and addressing any GFCI tripping issues is crucial to protecting both the vendors and the public. Also, regarding the question about one cord run to each booth incorporating the booth lights, fans, and/or small handheld tools, it would seem beneficial to separate the lighting from other appliances and tools on the same circuit to reduce the load on the GFCI and make it less likely to trip.